Okay, so quick revision on calculus, specifically on derivatives. By definition, f dash x is the limit as h approaches 0 of f of x plus h minus f of x over h, which you can think of as delta y over delta x, but with the limit as delta x approaches 0, which means we write it as dy dx, and this simply represents a rate of change. More specifically, the rate of change of y as x changes. And because you're talking about a delta x approaching 0, we'll refer to it as an instantaneous rate of change. And because our focus is now on graphing, that means dy dx, because it's the rate of change of y as x changes, is essentially the gradient. Because if you think about it, m equals delta y over delta x. That's what you learnt before we did calculus. So when you're taking, delta y over delta x over there, you're really just calculating a gradient over here. But because it's a gradient as delta x approaches 0, it's not just any gradient, but it is the gradient of the tangent to the curve at that point. Now, we've also defined some terms. We've defined the term increasing, which is basically when you've got an upward sloping gradient. In other words, m is positive, and therefore, in the context of our curves, that means the derivative is positive. We also have the term decreasing, which is when you've got downward sloping gradient. And if you've got a downward sloping gradient, that means your gradient is negative, which in the context of what the first derivative means, it means your first derivative is negative. Of course, we're leaving out one particular case here, and that's when the first derivative is 0, and that's when your gradient is horizontal of the tangent. In other words, we've got a horizontal tangent, and we call that stationary. And any point where that occurs is called a stationary point. Now, that's your very sort of brief rundown of the definition. But as a result of that, if a question asks you to find when the function is increasing, then Janelle, what do we solve for?
When it's bigger than 0.
True, but what's it? You need to be clear about that.
The derivative.
Which derivative?
Dy dx.
Yeah, and we mentioned last week, and we'll go more into that today, but we've got multiple derivatives, so the first derivative is greater than 0. Yeah. Mm-hmm. Can it equal 0 for increasing?
No.
No. All right, strictly. So if the function is decreasing, then Paris, what are we looking for?
Then dy dx is smaller than 0.
Can it equal 0?
No.
Right. And if the function is stationary, of course, that means you've got your final thing here. All right, great. So if we take an example question, and the example question asks us that fx equals x minus 2 root x, and it asks us to basically find the intervals where fx is increasing or decreasing, then your first job is to take the derivative. Now, hopefully that won't be very difficult here. So f dash x, just use the rules of, derivative of x to the n equals nx to the n minus 1. That's all you need to use for this one, pretty much. And I don't think you'll have too much trouble with this, so I'll just go straight to it. So this will basically be 1 minus 2 times, you bring in a half, x to the negative half, if you're thinking of root x as x to the power of a half. And that will then quickly give you 1 minus 1 over root x. And so you've got your derivative. Once you've got your derivative, then this is really two questions in one. First question is when it's increasing. And second question is when it's decreasing. So to answer the increasing part, you're basically saying that f dash x is positive, which means you're solving for 1 over, you're basically solving for 1 minus 1 over root x is positive. Does that make sense, Paris?
Yeah.
Yeah, and the rest of the remaining part of this question is simply just solving this inequality. So move the x to one side, the thing with x to one side. So let's move this with a negative, of course, to the right-hand side. And that will mean 1 is greater than 1 over square root of x. Now, because the square root of x is defined to be positive, we can kind of shortcut this a little and just multiply by the square root of x, because we know that has to be a positive number. And that will get us to the next line, which is the square root of x must be greater than 1. And if the square root of x must be greater than 1, that then leads you to your last line, which is square both sides. That means x must be greater than 1. Now, if you're decreasing, you would basically follow the same steps. This time, of course, because decreasing, you're solving it for less than 0. So you'll get 1 is less than 1 over root x. And then you would then, of course, do the same step as we outlined before. You'll get root x is less than 1, and that leads to x is less than 1. Now, looking at this question and knowing what you probably did, I'm suggesting, Paris, that this is the answer you got, that x is greater than 1 for increasing and x is less than 1 for decreasing. Is that right?
Yeah.
And so the reason you have a question, I assume, is because the answer would not just be this. There would be a condition of x is greater than 0, and that's what your question is about. Is that right?
Yeah.
Right. Okay. So that has nothing in and of itself to do with increasing and decreasing. So if that is where you're having the problem with this question, then I understand where your query is coming from. But it's not because you don't understand increasing or decreasing. It's that you need to think about this question. All right. So let me write out the question again. Now, what is the domain of this function? What's the domain of this function?
X greater than 0.
Right. And why can't it be, less than 0?
Because it can't be negative x.
Exactly. So it has a domain. And I said x is greater than 0. So when you say that, always think about this. Can it equal 0?
Yes.
Right. So your domain of this function is x is greater than or equal to 0. And as a result of that, when I ask you for intervals, well, x is greater than 1 is all within the domain, so that's not a problem. So for fx is increasing, you just say x is greater than 1. But for fx is decreasing, the condition is that x is less than 1, strictly. But the fundamental condition of the function itself is that x must be greater than or equal to 0. You can't be negative. And as a result, your final answer for the decreasing part would be x is greater than or equal to 0, but strictly less than 1. Does that make sense?
Yeah.
And I assume that was the sort of source of your query, like that's what you were not clear about?
Mm-hmm.
Great. So remember, as I've said many times before, it's not just about understanding your latest sort of things from before. So domain and range back from term 1. So make sure you always try to remember and apply, things from that we've learned before as well, as applicable to your current questions.